So hey guys, welcome back to the channel. Here we have discussed already different lessons on mechanics in one dimension. Today we are going to talk about another important topic, that is weight. That how weight acts on an object, what are the factors due to which the magnitude of weight differs, and we are going to talk about gravitational force as well. So in order to learn all the things, just stay tuned and don't forget to subscribe and like the video.
So these are the things which we discussed in the last class, and today onwards we'll keep talking about the next thing. So we defined few things in the last class. We talked about how this thing came into existence, how we got to know about motion, how we got to know about factors affecting motion. So first it was Aristotle, then there is Galileo, then finally came Newton. So we defined the following terms. We defined inertia, we defined types of forces, we defined types of forces, and then we talked about balanced and unbalanced forces. We defined what is force, how it can be defined. We talked about different types of forces. So how we got to know about force? So force was primarily given by Newton's second law of motion. According to Newton's second law of motion, it says that if an external force acts on the system, it is nothing but rate of change of linear momentum. Like what is linear momentum, which we just discussed in the last class. Like how much its velocity is going to change because of that force acting on the particle.
Mm-hmm.
So from
Wait, what's
this,
the
we got
like direct definition of momentum mean? Oh, measure of quantity of mass. That's
quantity of motion.
all motion.
So we got to know that force is nothing but it is directly proportional to rate of change of momentum. So when we remove this proportionality sign, we got some constant k. That constant k is supposed to be zero here. So we can
Mm-hmm.
write force is nothing but dp by dt, that is change of momentum, rate of change of momentum. So we can also explain this thing as delta p by delta t. We talked about it. Delta p is supposed to be p final minus p initial. That is what was final momentum by initial momentum. So we already discussed this thing that if there was an object and that object was initially moving with some velocity u, and we applied a force from the backside, so we will see that after a certain time its velocity changes to v. Considering the mass of the object is supposed to be 0. Oh, sorry, m. So p final is going to be mv minus mu divided by t, assuming it take t time to reach at this point. The force can be written as m, can be taken out as common, v minus u by t. The force is going to be m times a. So here a is nothing but the acceleration, m is nothing but the mass, and this is how we get the force. So this relation of force we got from Newton's second law of motion, and this is how it can be explained. Now just remember this thing, this is the net force acting on the system. The force is something which is capable of changing the inertial state of the object. Similarly, if there are more than one object, if more than an object is there moving because of momentum, because of external force, Such objects will be considered as system. So we need to keep this point in mind.
Mhm.
Like if there's more than two objects are suffering from the force or affecting with or because of force. So here the F net is going to be mass times acceleration, and here the mass is supposed to be the total mass. So acceleration of the system can be written as what is net force acting on the system divided by the total mass of the system. So this is how we are supposed to find out the acceleration of the any given system. So in order to understand the acceleration of any given system, we need to understand that how many forces are acting on it. And whatever number of forces are acting on it will ultimately give us the net force. So we already discussed how vectors can be resolved in all the directions. So whatever forces are there in the system, it will ultimately give us the net force by resolving those given number of forces. So this is going to be the net force. So if you remember, we talked about types of forces. So all these type of forces which we can see here like weight, normal reaction, gravity, spring force, friction, centripetal force, centrifugal force, and sometimes resistive and drag force. So all these forces, out of all these forces, any of the given number of forces will be there in the question, and we have to resolve that force. We have to find the net force, then only we'll be able to figure it out that what is the total, or you can say what is the net acceleration of the system. So this thing will be explained when we have the following things. Now let's talk about with from the perspective of motion of the particle. So suppose there was an object and that object was considered to be in following state. First, we can assume it is supposed to be at rest. Second, we can assume it is supposed to be moving with constant speed. And third, we can assume it was moving with variable speed. So I already gave you the idea about how the speed will help us to identify the state of the object. So if the object was moving with rest or object is at rest and or moving with constant speed, so we can say in that part that F net on the object is going to be 0. But if it is moving with variable speed, we will say that F net is not equals to 0. So if it is not equals to 0, we will ultimately say acceleration is not going to be 0. But here in the first case, acceleration is going to be 0. So what we can say about these things? So if acceleration is 0, F net is 0, it is supposed to be in equilibrium. This is another state of an object called equilibrium, which says when object is experiencing net force as 0, it is supposed to be in equilibrium. Means sum of all the forces along x and y axis is 0. This is what equilibrium term means. Whereas if net is not equals to 0, if net force is not equals to 0, it will give us non-zero acceleration, and that condition is said to be non-equilibrium. And in this state, we can simply say that the sum of all the forces is not going to be 0. That is, F net is not going to be 0. So this is the two states of an object. One is called equilibrium, other is called non-equilibrium. So you have to remember this thing as well. And in order to find out the net force, we draw a very special diagram that is known as free body diagram. So what this free body diagram says, or what type of diagram it is. So basically it is a diagram which helps us to represent all the forces in the form of vectors, assuming their given or specified direction. So we can simply explain it as that it is a diagram which represents all the forces acting on the object considering their direction in which they are acting. In whichever direction they are acting, we'll consider that and we'll apply the force in the given direction. Like for example, so I'll be assuming few things, or you can say the few situations where different type of forces can act. So this will also give you the idea that how different forces act on an object in different situations. Like the very first situation, that you can consider it as case one. So in case one, what happens is that there is one object lying on the surface of the earth, like that. So here what happens is this object, because of having some mass, because of gravity acting on it, it will have some weight acting in the downward direction, which is supposed to be equals to mg. What is mg? M is the mass, g is the acceleration due to gravity. Whereas, as this force acts on the surface of Earth, the surface of Earth will also apply some external force, or you can say this will also apply some reaction force. So that reaction force will act from the surface of Earth, which is supposed to be normal reaction. And this normal reaction in this case is equals to again mg. So here we can say, so normal can be written as mg, like that. Similarly, let's talk about some other cases as well. Now I'm assuming a system which is constrained. Like I'm assuming a system which has a pulley in it, and the system has two masses connected over one another, like that. I'm assuming that the mass of this particle is m1, this particle is m2. So here, what will happen is, always remember whenever there is any question from this particular topic, you just have to mark first mg, that is weight, then you have to mark normal, which is always against the surface. If there is no surface, if the object is in air, then there is no such force will act. So here mg is going to act downward, so you can write m1g here as well as m2g here. Similarly, as these two masses are constrained or connected with a string, so there must be some force in the string that is known as tension in the string. So there are few different forces that are acting here. The first is tension. We'll talk about the property of each. Then there is m1g, that is weight of the first object, and this is going to be the weight of the second object. Weight will always act in the direction of g, that is acceleration due to gravity. So here we can find out the value of tension, we can find out the value of acceleration of the system using Newton's second law of motion, that is F is equals to ma. Remember that. Then I can assume another case here in order to give you an idea about how another type of force, that is friction, act. So suppose there is an object of certain mass m and we apply some external force in this direction. So what will happen here is, as the surface of the object and the surface of the earth is in contact, so there must be some friction force that will be acting in the backward direction. Assuming all the forces stays the way they are. So mg will be acting in downward direction, whereas normal will be acting in the upward direction. So here we can see that there are four forces acting. In the horizontal direction, there is external force against which friction is acting, and in the vertical direction, there is weight, that is mg, against which normal is acting. So in order to understand it, we need to understand all the types of forces, and ultimately we'll get to know more about it. So majorly in your syllabus, or you can talk about the lesson 2, it has weight and drag force. So we have to talk about weight and drag force, and this will ultimately let us understand how things are going on. So we have to discuss number of forces, but first we'll start with weight, and then we'll talk about drag force. So weight will define as that it is a force which acts due to gravity of a planet. Remember this term. We not only define weight for Earth, we can define weight for any planet.
Okay.
So suppose there is an object and it is placed on Earth, assuming it has some mass m. So weight is the force with which that planet pulls that object. So you can define it as in another way, that it is the force with which it is pulled towards the surface of Earth. Like whatever object you drop from a certain height, it always comes to the surface of Earth. Why? Because of the weight. Because weight is acting on it, and we can say it is the force with which it get pulled from the planet towards itself. So remember, this is a type of force. So if it is a force, it must have some direction. The direction of force, direction of weight is always towards the center of Earth. Direction of weight is always towards the center of Earth, या फिर center of planet. Like for example, suppose we have a particular planet like this, and in that planet there are two objects. One is kept here, another is kept here. So whatever planet it is, it doesn't matter. What matters is that how this planet is going to pull that object. So it is always directed towards the center of the object, Earth, center of the planet. This is how this mg is going to act. Its direction is pretty much simplified, whereas if we talk about the magnitude of force, we already know what is magnitude. So magnitude of weight is always equals to mass times acceleration due to gravity of that planet. Why I am referring to that planet? Because for different planets, the value of G is going to be different. So we not need to understand the same thing for Earth only, but for any other planet, if it is there, we need to understand it for that. The magnitude of weight is going to be mg. Similarly, we need to understand this thing that it is a property, or it is a force which acts due to planet's gravity. So it is a property of planet. For different planets, G is going to be different. Like for example, if we talk about Earth, it is 9.8 meters per second square. Similarly, if we talk about Moon, it is 1/6 of gravity of Earth. So that is again a new number that you need to remember. So in all the cases, weight is always equals to mg. Let me show you how. So suppose there was an object, it is kept on the surface of Earth. Similarly, there was another object which is kept on an inclined plane of some angle theta, like that. So in both the cases, if I assume that the mass is supposed to be same, so in both the cases, weight is acting in the downward direction, which is going to be mg always. It doesn't matter on which surface it is kept, but what matters is that weight is always in the downward direction, or you can assume it as perpendicular to the surface on which it is kept, or you can say on the ground in which it is kept. The direction of weight is always perpendicular to the ground, and its magnitude is always product of mass and gravity. So this is how the weight is calculated. Like for example, there is a small question. The question says an object of 5 kgs mass is dropped from certain height. So the question is find its weight. So how can we find its weight? So we can simply say that weight is nothing but product of mass and gravity. If we didn't mention the planet name, so we'll consider it to be Earth always. So mass is 5 kg, g is 9.8, so weight is going to be 49 newtons. This is how we are supposed to find out weight. Just simply multiply mass and gravity of that planet. Similarly, let's do another question. Question says an object of mass 10 kgs weight 98 newtons on Earth and 45 newtons on certain planet. What is acceleration due to gravity on Earth as well as on the planet? It's not all about that they always ask about weight. They can also ask about different things. So how can we find acceleration on Earth as well as on another planet? So we know that weight is nothing but product of mass and gravity. So acceleration due to gravity means we have to find out about g. So g on Earth is going to be weight on Earth divided by mass. Mass will always remain same. It doesn't matter which planet it is. It is going to be 9.8 meters per second square on Earth, as we already know. Similarly, for another planet, it is going to be weight on that planet divided by mass. That is going to be 45 by 10, that is 4.5 newtons or 4.5 meters per second square. So this is how we are supposed to find about weight and its related properties. Always remember, weight is mg and the object's weight might change if there is any another force acting on the system. So how the forces acts on the system and how many types of forces can actually change the weight. We'll talk about the same in the next class.